Hello my dear friends, welcome to the YouTube channel Math Skill. Let's learn mathematics together. The aim of this channel is to help students overcome the fear of math by learning the concepts clearly. In this session, let's try to discuss about the chapter Introduction to Trigonometry and the numerical. What we're going to solve is a solved problem from textbook. That is, if angle B and angle Q are acute angles such that sin B is equal to sin Q, then prove that angle B is equal to angle Q. This numerical is a part of CBSE as well as NCERT for 10th standard mathematics. I am your trainer Venkatesh K. Now let us see how to solve the problem. I have noted down the problem wherein the expectation is that if angle B and angle Q are acute angles such that sin B is equal to sin Q, then we will have to prove that angle B is equal to angle Q. Let's start the solution. Let's consider two triangles, triangle ABC and triangle PQR, such that it is given that sin B is equal to sin Q. Now let's draw the diagrams. First triangle is triangle ABC and one more triangle, triangle PQR. Also it is given that sin B is equal to sin Q. In first triangle, let us try to apply sin of angle B. So for angle B, sin would be opposite by hypotenuse. So for angle B, opposite is AC. Similarly, in triangle PQR, for angle Q, opposite is PR. In both the cases, hypotenuse would be the side which is opposite to right angle. That is, for angle C, opposite side is AB. That is, in triangle ABC, AB is hypotenuse. So similarly, in triangle PQR, for angle R, hypotenuse would be PQ. Now let us note down the given condition. The given condition says sin B is equal to sin Q. Let's note down. Sin B is equal to sin Q. Now, in triangle ABC, sin B is opposite by hypotenuse. Opposite is AC by hypotenuse is AB, as we have just seen. So similarly, in triangle PQR, opposite side for angle Q is PR divided by PQ. Let's swap the terms. That is, AC by PR is equal to AB by PQ. So what did I do here? I have taken AB from denominator of the first term towards the I have taken AB towards the second term. Upon transpose, it would become the numerator. Similarly, PR would be now the denominator of the first term. That is, AC by PR is equal to AB by PQ. Now let us call this as equal to K, where K is a positive number. Let us call this as equation 1, wherein K is a constant. Since ABC is a triangle in which sin B and sin Q are applied, which means trigonometry can be applied only in case of right angle triangle. Therefore, let us apply Pythagoras here. In order to apply Pythagoras, let's start with the triangle ABC, wherein angle C is equal to 90 degrees. So in here, Pythagoras theorem states that square of hypotenuse, which is AB square, is equal to AC square plus BC square. By applying Pythagoras theorem, AB square is equal to AC square plus BC square. Now, let us retain AB on one side and transpose the other entities, that is AC square towards the LHS. So AC square upon transpose towards LHS plus AC square would be equal to minus AC square. That is AB square minus AC square is equal to BC square. Or let's take the terms of RHS towards LHS and the terms of LHS towards RHS. Therefore, BC square would be equal to AB square minus AC square. We have just now found AB by something is equal to K. Let's substitute the terms here. That is AC is equal to K into PR and AB is equal to K into PQ from the previously observed statement. So I have taken AC in terms of a PR and AB in terms of PQ. Let's substitute AB and AC here. That is BC square is equal to AB square is K into PQ whole square minus AC square is K into PR whole square. Now this looks like the theory of indices formula, that is A into B whole power m, that is A into B whole power m, that is A power m into B power m, that is K square PQ square minus K square PR square would be the next term. That is BC square is equal to K square PQ square minus K square PR square. Let's take K square common on RHS, that is upon K square being taken as a common, PQ square minus PR square is what is left. We want BC. Let's move the square to the RHS so that it would become square root. Therefore, BC is equal to K into square root of PQ square minus PR square. Let's call this as equation number 2. Similarly, let's apply the Pythagoras theorem for the one more triangle PQR. Let's do that now. So applying Pythagoras theorem for triangle PQR, since angle R is equal to 90, we can apply Pythagoras theorem here. So here hypotenuse is PQ as we have seen earlier. So Pythagoras theorem would state that PQ square is equal to PR square plus QR or RQ square. Therefore, we want QR on one side. Let's retain QR square on one side and transpose the PR square towards the LHS. That is PQ square minus PR square is equal to QR square, or QR square is equal to PQ square minus PR square. Since we want QR, so QR is equal to square root of PQ square minus PR square. Call this as equation number 3. Now let's divide equation 3 with equation 2. That is 2 divided by 3, we would be getting, we had BC there. So BC by QR is equal to K into square root of PQ square minus PR square divided by PQ square minus PR square within square root. Now these two square root terms will get cancelled. Therefore, we would be getting BC by QR is equal to K. Earlier, we had seen, which we had called as equation 1, wherein we had got AC by PR is equal to AB by PQ is equal to K. So here we have got BC by QR is equal to K, which means all three entities, that is all three ratios would be same. That is AC by PR is equal to AB by PQ is equal to BC by QR. So everything is equal to K, which means that the corresponding sides of two triangles are proportional. So since the corresponding sides of two triangles are proportional, therefore triangle ABC and triangle PQR are similar. Triangle ABC is similar to triangle PQR, which means angle B is equal to angle Q. By application of the similarity in triangles theorem, so the corresponding angles would be equal. This completes the proof. Thanks for watching the video. Take care.